In the world of firefighting and public safety, reliability is key. That's why for over 2 decades, first responders nationwide have trusted the Fire Store as their go-to source for essential equipment, apparel, and accessories. From top-of-the-line firefighting gear like helmets, boots, and thermal imaging cameras, the Fire Store has it all, tailored to the specific needs of our heroes on the front lines. But they don't stop there. Their extensive selection also includes EMS supplies, safety apparel like flame-resistant clothing and high-visibility gear, as well as a wide array of tools from hand tools to vehicle extrication tools, supporting public safety professionals in their duties. Partnered with industry leaders, the Fire Store's commitment to quality and excellence is unmatched because when it comes to protecting communities, there's no room for compromise. Join the thousands of first responders who rely on the Fire Store. Visit thefirestore.com online or in store today. The Fire Store, your reliable partner for fire and public safety equipment. Hi, this is Chris Mc Loone with Fire Apparatus and Emergency Equipment. Welcome to this edition of our podcast. I am with Ricky Riley today. He's a member of our advisory board, FDIC instructor, and one of our leading apparatus guys that we call on quite a bit. We lean on quite a bit, not only for his expertise on in training at FDIC on this stuff, but also for articles every so often, and of course the podcast. Today, we are going to talk about pump panels. And while that is it's not a dry topic, but it's not certainly one of the most exciting ones that you're thinking about when you're building a fire truck. But the pump panel, an efficient pump panel, a well-organized pump panel, a logical pump panel is going to lead to a more efficient fireground when you are looking to move some water, when you got fire blowing out of the second floor window of a two-story single-family dwelling, and you don't want to be sitting there, kind of looking at this thing going, I need a map to figure out, what discharge is piped to what valve. So, but at the same time, sometimes trying to overthink it and make it too pretty looking or too logical almost works against you because of what has to happen on the back, on the other side of the pump panel in terms of building that pump and manifolding and all that stuff. So those are some of the things that we're going to get into today. Ricky has been around volunteer fire departments, career fire departments, and combination fire departments. So he's got a variety of ways of looking at this, because coming from the career side, we're all about customization, constant, customization. Although you have mentioned how there's like 14 lines of options on your bumpers at your current department, so there's a fair amount at the municipal level as well. But a lot of times when we get into the municipal side of the more urban fire departments, they're building not cookie cutter rigs, but they're building rigs according to a spec, and it's going to be that way across the city, unless there are some specific target hazards that require something a little different. So these are some of the things that we're going to get into today. Ricky, I wanted to start with you on just getting water into the truck. This is something that a lot of people do a lot of different things. I know the rigs that are at my firehouse right now, we haven't had an intake valve on the driver's side of the truck for probably 5 trucks now, 5 pumpers now. The last ones were the LaFrances that we had back in the day. We've been a lot of times, we've been going on an intake in the through the bumper. Or sometimes from the rear. So we haven't really done a whole lot. We don't really do a whole lot on the side. We would probably save the steamers on either side for drafting. But what is your take? What is your feeling on LDH intakes on the driver's side of the pump?
Well, I mean, it kind of goes back to when we're talking about getting water in the rig. Let's go to that. With that question first. You said about that's probably one of the most important things I think that fire departments need to focus on is that how you're going to get water into the engine, because that's what the engine's there for. It's, the all the stuff that we add on to it, bulletproof vests and ballistic helmets and surfboards and extrication tools and salvage equipment. That is all just extra stuff that we're piling on the basic engine company. I mean, go back to the history of the fire service. Wagon and pumper. It was one truck pumped the line, the other carried the hose, and that's how we put fires out. So when you focus your engine company around water, then you're on a good path for your design or your specification or how you're going to make your rig operational. So once again, it depends on where you're at, geographically, what your response area is, what your hydrant system is, if it's rural water supply, how you're going to get water into that rig, and then what the cause and effect is. So obviously, almost every fire truck has 2 steamer caps. Depending on the size of your pump, it's going to tell you what size that steamer is. So what you do to each side of that steamer on the driver's side or the passenger side is entirely up to you as an organization. So most of our organization is a Akron valve, with a big handle that's on there. There's other manufacturers that make those. I'm not being specific to them, but that's our LDH intake on the passenger side, and you can also draft out of that. Also, you just need a 4-inch adapter, to a threaded, to a threaded 6-inch or whatever size, hard sleeve you're using. But now as we go around the truck, like you said, front intakes. I mean, that's with fire trucks being red, a front intake is what it is. To me, I mean, every fire truck should have one. It's great for hooking up the the municipal water systems, and also good for drafting. Depending on how that pipe runs through the chassis, how it runs through the wheel well, how many bends are in it, which actual flow you're going to get out of it, is pretty important. Then once again, even if we're not going to do a drafting evolution, let's say for that front bumper, is that, how we're going to hook it up to the hydrant, and then how we're going to get water in. That water coming into that front intake doesn't have to be from, a municipal water supply or a hydrant. I got to give a lot of credit to, now as a chief, Chief Larry Williams in Clearwater. I always say we got to put this front suction on. We're going to put these front suctions on, and he was like, "Well, we need an adapter so we can take water in, from that front if we don't want to clog up the street with 5-inch LDH, what they used in Florida." So for a cost of a $800 6-inch female to a 5-inch Storts, we created another inlet that normally we would never use. I felt bad that my brain had not done that before. And Chief Larry Williams, he was a lieutenant at the time, and come up with that. And then as we go around to the back of the rig, a lot of departments now are using a rear intake. And once again, it could be the same thing as the front. All we got to do is hook in an adapter, and we can take water in either from a municipal water supply, or if somebody's feeding us, a 5-inch supply line, or a 4, so LDH, whichever they're doing. The only thing I don't like about the rear is that sometimes that rear suction will bump up that rear hose bed, depending on the size of the pipe, or if you're going to run the pipe through a compartment, then you're going to lose compartment space. So it's what your fire department wants. It's a give and take piece. Now on the driver's side pump panel, it's entirely up to you. I think right before we got on the show today, we called our buddy Eddie Rice, who was on the 1900 committee, and the only thing that NFPA 1900 pretty much states is that, hey, you can't have these large discharges where the pressure is going to be much greater than an intake. So, if you want to put a Akron Revolution valve, or, name any other manufacturer, or we use gated Siameses, so we can hook the 3-inch line in, and get more water in. So, I'm all for about having all kinds of way to get water into the rig. One of the big things that you see a lot in our area is what we call a heavy hookup. Whereas, rather than just 2 3 inch supply of lines off the hydrant, or just your front soft sleeve or your rear soft sleeve, is that, they'll put, hydrant gates on both spuds of the hydrant, or they'll put a humid valve on this thing and then try to get as much water out of that hydrant as possible. So you have to have places to put that. So if you're going to use 5 inch or 4 inch as your intakes, you're going to have a intake on your passenger side, intake on your driver's side, or you're going to use your front and your rears. So that heavy hookup is come in, incredible on a lot of big fires, because the hydrant pumper is not running out of water, and they're sucking every bit, not sucking because they're not drafting, but they're getting every bit of water out of that hydrant that's possible, rather than just, the front cap. So, any way we can facilitate that, either through specifications or through the use of adapters or good thought process, is what's important about getting water into the rig. I mean, like I said, I've done front intakes my entire life, and never thought of it as a intake from a supply line rather than just a hydrant. So once again, thinking outside the box, I'm sure all our water supply gurus, the guys that you've been having on the shows lately, who deal with rural water supply a lot, but that municipal water supply is important also, getting all that in. So any way we can get it in, and it does not matter to me if the gate for the LDH is on the driver's side or the passenger side, as long as we're able to get water in. So I know that was a long answer to your short question, but
No, not at all. And it's interesting, just some of the things that you were saying. And as you were speaking, I was thinking back to when I first joined Weldon, and we had the intake on the driver's side. Now these were 81 LaFrances. There were really only two large diameter intakes on the truck. And I can still picture, our old chief engineer, standing there. Was kind of like one of those deals, 1 foot on the step, and one hand, I could picture him like, he's got a hand up here, he's pulling a valve, but he's also got like a hand on top of the 5-inch that was connected to that. And that was just one of those things. It was, when it was a shift when we bought, our 97s, putting that intake valve on the other side, you lost, temperature wise, you could feel, through that when the water was getting too hot or something like that, or so you needed to recirculate, or that, that the pump was getting too hot. Now we got to kind of feel a little bit past the pump panel on the pipe. But also, you could see signs of cavitation a lot quicker. If you happen to not be watching the panel a little bit, or if you're, I don't know, back then, God, the generators are like these pull things, and if you're struggling with that in the back of the truck, you can at least, and you're not hearing what it sounds like when it cavitates, you can see the hose collapsing a little bit. Just little things like that I kind of came up with, but then we did shift gears. I can't think of, though, once we had front and rear intakes, I can't think of a time that I ever used a side one again, unless it was a large diameter hose evolution where we wanted as much water as we could get out of that hydrant. So we hooked up a hard sleeve to the hydrant right into that steamer connection on the passenger side. But interesting, when you were talking about using connecting not to a hydrant, but a supply line to the front of the truck, that actually happened. There's this one district in my township where the hydrants are, to me, have always been kind of funky, their locations, and it turned out in this case the one that was taken was down, and I was pointed in the direction that they were coming, so they drove right up, took the 5-inch right through that front intake, and it's kind of a straight shot at that point. So interesting stuff. I just wasn't sure, where you were at with that. Some of the safety guys definitely don't want any hose on that side of the truck coming in or going out, So I was just curious on that. Now, I mentioned before that you've been in the volunteer side, the combination side, and the career side. And so with that experience and the different departments, and different needs that you've been exposed to, what is the most effective way to set up a pump panel? And I guess that's not really the right question, because effective could mean different things to different people. But I mean, like I'm just thinking in terms of ease of use and stuff like that to create an efficient an efficient fireground.
Yeah, I mean it's across all of them. I don't think a lot of people. I mean, I'm sure there was a lot of people before me that did this, but I mean, a lot of thought put into the pump panel. I mean, it was, yep, we're going to get a pump panel, and it's going to be a 1,500 single stage pump, and we're going to have discharges on the driver's side. We're going to have discharges here, front and rear, and then they just kind of go, all right, manufacturer, just that's it. We want the pressure governor here. We don't even tell them where they're at, even though as we build apparatus, now we know we all have to sign off on the pump panel layout and where everything's at. So now it's just a matter of what each individual organization, geographic area, and response area tells you how to do things. And it's very interesting to watch across the country the different pump panels like you're talking about. Is that what a pump panel that works in the Midwest, we would never think about having something like that. And it's not about the water won't come through the intakes, the water won't go through the discharges. It's just how they set it up. I mean, for us, it's about a small pump house. So in our area, in the Washington, D.C., Baltimore, area, and outside of that, I think our departments strive to have shorter fire trucks. Just very, very short fire trucks. But our missions are very singular with those pumpers. I mean, it's water in, water out, and then probably ALS equipment and EMS equipment, and that's pretty much it. Whereas, as a department that, that isn't our organization, may have to carry all this extra equipment, whether it be rural water supply equipment, tech rescue equipment, auto extrication equipment, whatever they're going to carry. As their pumper grows in wheelbase, that affords them a little bit more space in the pump house. But once again, it's a choice. I mean, if we're going to talk about Wichita, Wichita, Kansas here in a little bit, is that, they design a great fire truck. I mean, I know a lot of guys on the committee there, nice low hose beds, built for their fire department, how they operate. Their pump panel is very clean, but for us, they're very big. But they're not dealing with a small, tight, urban, old city. Because I'm in Washington, right outside Washington D.C. There's a lot of tight streets. A lot of the original early 20s and 30s homes and everything. So the streets are still small. Whereas Wichita's got a little wider streets. There's not as much as to deal with alleys and getting in those rear alleys. So they can have a pumper that's a little bit bigger, so their pump house can grow a little bit. So let's bring that up, the picture of the entire fire truck of Wichita up, because I know I'm getting off topic here. We're going to get on it. Man, for us, this is an extremely large fire truck for our organization and our area. But guess what? We're not Wichita. So that fire truck goes as fires, puts fires out rather well. The crews are well trained, and this rig works for them. And that pump house is huge to us. So that's probably almost a 60-inch pump panel, where we're dealing with a 45. So that offers them a lot of different opportunities. So, if we go to that next picture of the pump panel, Chris, please. I think, yeah. So this is their pump panel up close. And, forgive me, the cropping is a little bad, but it gives you the idea of what it is. So they have all their gates are in a straight line. Everything's properly labeled. But obviously, and behind that pump panel, there's room. Obviously, with a 60-inch pump panel, and it's probably maybe be a little bit more than a 60-inch pump panel. I didn't look at their print today, But if you look at it as compared to ours, which we'll show you here in a little bit, there's a lot of room on the pump panel itself. It's not all tightly compact, and then behind it, all those valves are in a row. It's all direct linkage. They're able to close those things and open them. They're all very well labeled. They're how they're laid out on the truck. Obviously the one all the way to the left or toward the front of the truck is the front discharge, and then it goes all the way to the back. So once again, then they got their two, LDH or their LDH or large discharges with the slow close valves up at the very top of the pump panel. So very well thought out pump panel. Works for them. Is obviously it's and it's standard now, I believe, because the last couple of rigs I've seen of theirs have had this same pump panel. So once again, their operation, their geographic area, how they operate as a fire department, and then how they standardize it, which is the most important thing, I believe. So having a career fire department, a combination fire department, or even an all volunteer fire department, is that I can't go in and drive engine 1, and then the next day I got to drive engine 2, and I'm searching around, where's that discharge again, or where's the pressure governor, where's the tank to fill. So they've kind of made a very good standardized pump panel that's big and has a lot of room behind the panel, and we'll talk a little bit about that here in a little bit. So once again, a great pump panel. And, they obviously, you can see they have their 6-inch steamer on the side. I do not know what Wichita does that. So let's go back to that first picture of Wichita, and that'll tell us right away what they do there. Oh, so they're taking in water in that steamer. So obviously they have a valve on there, whether it be behind the panel, which I know we're going to talk about electric valves, whether it be a electric valve behind the panel, or if it's, like a revolution valve, or, I wish I had a correct term for that, so I'd stop using the brand name. But so they have a manual valve on the outside of the pump panel that they can take that water in and open and close it as they need. So a great design, great department, and they have a thought process behind it. So did I?
Well, and standardizing those pump panels is critical in a larger department for the reasons that you just said. Going from engine 1 to engine 2, depending on how the crews beat them a little bit. There could be some nuances there, but knowing where everything is located and almost not having to think, so it's muscle memory is critical when you're moving from rig to rig. If you're detailed somewhere else, or I can think. I have often looked at other pump panels in our township. We'll be at like a fire school at another station or something, and I'll walk around and I'll look at them. And my pump operations 1 and 2 instructor, and this is years and years ago. So, but he was big on saying if you've pumped one truck, you can pump any truck. And he's right to an extent. But but I would look at them and I just think, well, what if things were hitting the fan? Would I be able to get water out of this thing? You just kind of look at it, because I don't train on their trucks. We're each our own little fire company in our township, so we've all got different specs, for the rigs. So I've just so I know, just doing that, how you're just kind of looking at it going, now, the tank to pump are usually low and the recirculate's usually higher. Sometimes they're right next to each other, depending on the thing. So I'm confident I could get water, but it would probably take a little bit of head scratching initially, to know that. So that muscle memory and that standardizing across the department is critical. I'm sorry, you were about to say something.
No. You're perfectly right. I can go get water out of Wichita engine 2. Don't count on it getting quickly. Because I know the steamer down are my intakes and steamer up are my discharges, but where that discharge is, where the handle's at, where the pressure governor's at, if I'm, switching from tank to hydrant, that's all, those are all important pieces. I'm, in other words, my hometown fire department, Ocean City, when I still visited, still not a member, drove the wagon, I hooked up a 4-inch discharge, and I'm like, where is the handle? And it took me a long time. And finally somebody comes up who drove the rig every day and just opens it, and I'm like, oh yeah, big city fireman, man. He got this down pat. But understanding engine one to engine two, and we did the same thing for our pump panels. I can't remember the reason, but we obviously we kept our pump panels are always 45s, but we found some room somehow on the pump panel. We moved something, but we were going to move like the pressure governor to get it to a better spot. But I'm like, we can't, because there's 14 other engines that have the pressure governor in this one spot. So, if you get detail from engine 46 to engine 2, the pressure governor's in the same spot. Your tank fill's in the same spot. The same things you just kind of talked about. That's important. So, we didn't change that much. We said, no, we want to keep everything standardized in the same spot. And then, once again, I'm sure there's a big change. This wasn't the pump panel for Wichita forever. For the last, 2 decades. Finally go, all right, we're going to make this change. Here are the reasons why. And then from now on, this is what we're going to do. And as long as you don't change it, every order, you're going to get some kind of standardization. Man, go back to Florida when we're talking about, that front intake, is that, those we bought in 10 years, we've replaced every pumper in the fleet and a lot in the reserve fleet. But every pump panel was standardized. It was, here are the discharges, here's where the gauges are, and all that. So that's an important piece of designing that pump panel. And we got a couple questions later on to elaborate on some of that pump panel stuff, but it's an important piece. I mean, it's not as important to me as it used to be, as to the person that's driving an engine every day, but to those people that drive the engine every day and they're dedicated engine drivers, that panel, how it's laid out, how they're able to operate, their hands, like you were talking about, feeling the supply line, or how they're going to get to the pressure governor. If they, if they've got this, 2.5 discharges and they got a 4 or 5 inch coming in, they don't want to have to be, circling their hand around there to get to those the devices. So.
It's funny you mentioned that about the guy who came over to find the handle for you. I'll tell you, when I was a new pump operator and the chief engineer would come up to me at a job, and he was always good about it, but he'd be like, "You okay?" And as a young buck, I'm thinking, yeah, of course I'm all right. What's the problem? You see, like I'm in my head, I'm getting like an attitude about me. But these days, there is no better feeling than that chief engineer walking up and going, "You all right?" Just to make sure. It's interesting, with age, it kind of mellow out a little bit, and it doesn't bother me quite as much. But I'll tell you, back in the day, it would be like, "Yeah, I'm fine. I don't need you staying." It was that.
Oh man, those older engineers, they could hear in the engine RPM that something's going on, or they look at a gauge and tell you that that something's happening to the pump, and you're like, "What are you talking about?" And nobody said anything on the radio. Everybody seems to be doing okay, and sure enough, something's happening with the pump, or something's happening with one of the attack lines, or the supply line, or something. So.
Well, you touched on something when you first started talking about the effective pump panel, and that was talking to the manufacturer and letting them know. I was wondering if you could just elaborate on that a little bit. Just talk about how important it is to make sure that the manufacturer knows what you're going to do. There are a lot of moving parts in putting, just designing the pump panel is only one part of it. The pump has to then be designed so that everything fits the panel that you created, but also, it can be dangerous to just say, we want this number of discharges, and whatever you come up with, we'll work with, because then it becomes what they're building is not what you're probably thinking of in your head. So just talk about how the importance of that. The pre-construction meeting, and making sure that the specs are dead on with what you want, because you don't want it. It's not like moving a shelf, because the piece of equipment didn't fit the way you thought it was going to. If this isn't what you want, you're kind of stuck.
Oh, for sure. I mean, it's if you leave it up to the manufacturer, they're going to design it for themselves. They're going to make it easy for them. Not easy for us. operationally. So I mean, I go back to, our 45-inch pump panel. I mean, we got a 1500 GPM pump, and we're one, two, three, four, five, six, seven, eight, almost nine to 10 discharges. From a wagon pipe all the way down to a bumper line, and so now we got to squeeze all these valves in there, or the handles, and then we got all the drain valves. Valves got to be on there, and then anything electronic that we're doing, the slow close valves for the the LDH, or for the deck gun, or how we're going to do that. Even for our deck guns, it's a dual valve where you can close the valve at the pump panel, or you can close the valve upside in the dunnage area at the deck gun. So now we have these rods coming through from the top and the front to get all this down. So then I'm telling the manufacturer, oh yeah, I need this in 45 inches. This is the way it's got to fit right here, and in this pump house. And if the mechanics, until we really started listening to them, we would just go, here's the pump panel. It's a huge pump panel, and we didn't. I know we got it as a question, but we might as well get on it now. Is that we weren't putting access panels for them, and most of the time, with every fire truck, there's an access panel on the passenger side, and that's all well and good in like a Wichita pumper, where when you take the access panel off the passenger side, it's a large space. You have 60 some odd inches of space in there, to put your head in, to put your body in, to put your tools in. You can see the valves, and shrink that down to a 45. You may only be getting to the half of the pump, half of the discharges, because it's all crammed together. The pipes are all running through there to get to the rear discharges, to get to the deck gun, to get to the front discharge. So that is a kind of a big deal. So when we tell the manufacturer that's what they want, they have to come back and say, yeah, we can do it, or yeah, we can't do it. There's times when we were talking about putting electric valves back into the on the side intakes, and they're like, oh, you have no room. That's a big valve, on the front, and for the side. If we were going to put an electric intake on the steamer, an electric intake on the passenger side, that takes up a lot of space. Then we have all the gauges we got to put in, all the tubing that has to go in for that. So, having that good engineer at your OEM, or if you're a pump manufacturer that you choose, whoever that may be, a lot of, we've had a pump manufacturer approach us about having them build the pump house and then ship it to our manufacturer. So it's kind of it's something that needs to be dealt with. And what we are finding with our rig, and and I don't see anywhere on our questions today, is that now we're dealing with the friction loss of all our decisions.
Mm-hmm.
So
right.
It's really great. We got a 29-foot pumper, and we got a 45-inch pump panel, and we can scoot through intersections, and we got this nimble fire truck. But what we found with the pump is that we're having a real difficult problem with the friction loss inside the pump and inside the piping. So I'm going to get a little off topic, Chris, and you can reel me back in when I get over it. Is that we tell our manufacturer we want a 1500 GPM pump. We want it to be single stage. We're going to have 9 to 10 discharges, and then it goes to pump testing at the manufacturer. It gets their third party testing, and then let's just say we bring it back and then we test it. Yep, all the discharges work. It's all great. But the thing that we started doing a couple years ago was actually taking the rig out and doing flow testing with it. So we have a general order or a policy that says you have to flow X amount of GPM in a structure fire in a single family dwelling, and then you have to flow this many GPM at a multifamily dwelling, garden apartment, or a commercial. So we were like, all right, let's take our friction loss charts wherever we got them from, from our state fire school or from our own fire department. Let's apply them to this pumper, and then let's put the flow test kit on the nozzle, or and see what happens. And what we found out is that there was no math anymore, and that was the most shocking thing to me, is that we were achieving our GPM at the end of our line, whether it be a 400-foot line, 200-foot line, a 250, a 300, we could achieve the GPM through the pump, but there was no math to back it up. So no matter what math we did, we could not figure it out. And what we were figuring out, it was the pump and the fire truck that is more or less causing all these problems. I mean, look, I mean, hose manufacturers and nozzle manufacturers, they are more involved in the fire service than they've ever been. I believe in a support role. So, the hose manufacturer, the nozzle manufacturers are the ones that got us to do this. And then they come out and help us do it. Not that, see, our hose is better than their hose, or our nozzle is better than this nozzle. It's this is what you're getting out of your nozzle, this is what you're getting out of your hose, and this is what you're getting out of your pump. And that's all through, pitot gauging and, putting pressure gauges everywhere on the fire truck to figure that out. And we ended up coming up with a pump chart that is more or less based on the pre-connected lines that we have on the rig. And we know that if you pump it at this pressure through this fire truck, which all our fire trucks are the same, the pumpers are the same with a 45-inch pump panel. All the discharge has been the same since 2016, and all the piping is the same, is that this is the flow you're going to get. And that is, you want to talk about blowing some people's minds. I mean, like, how can you not have math? Where's the Q square come in? Where's the Q come in? How is this not and it was, puzzling to me. I mean, I'm getting ready to go back through a pump school again. Just, to kind of brush up on that. I mean, I don't drive an engine every day, just to go back through some of that math and see how it's actually going to be applicable to our rig. Because, I mean, if you're an engine driver, if it's a 400-foot line and we know to flow at X amount of PSI, and we're going to get, our 150 or 175 gallons that we need out of the end of it, what happens when I need to extend it? So if I need to add another 100 feet on or another 50 feet on, what am I bumping it up to? Because more or less it's going to be a guess, because, I'm sure we haven't got a pump chart for that. Now I need to do that apparently, because I'm just thinking that is it. Redo the pump chart, redo the flows. But, our pump was causing these problems because, if you take our pump panel off, you take that black pump panel off and look behind there, I mean, the piping is every kind of angle and there's bends in it, to get it around this pump house, to get it to go into the body, to go to the rear for our discharges. So, even looking at, your front discharges, where it's coming out, it's going up around the wheel well, back down. And then what kind of piping is it? Are we using, hard rubber flexible hose, or are we using, stainless steel, pipe? Once again, friction loss, how quickly water is going to move through it. All huge things that you have to consider. And, the best thing that I can tell you is that, not only do your third-party testing at the manufacturer, but come back and flow every one of your lines through your pumper and use the pitot gauge, use pressure gauges, all those manufacturers, TFT, Akron, Elcar, all of them make test kits for that. And learn how to use it correctly is the big point. Is that don't just go back, I read, fire pump operator manual from 3rd edition, and they told me this is how I do it. The technology in the testing equipment is pretty incredible also. So, that all comes a part of that pump panel is that, this, I would imagine that, the Wichita rig, like we're looking here at, probably has a pretty low friction loss just based on the lack of bends that it probably has to get to the rear discharges, unlike ours. So, Chris, see if you can bring up that driver's side photo. Should be, keep going. Keep going. Keep going. It's my fault. It's not your. So like that's our standard pump panel. So you see we got the gated inlets. It's 45 inches wide. And, you can see we have an access panel there. And then all the discharges are kind of laid out there. So it's pretty simple for us, but it's small. I wish I'd have taken a picture without the access plate in place so you could see the mess behind there. But now if you can just go to that next picture, it should be the driver's side, Chris. So, I mean, once again, pretty simple. One discharge, an LDH discharge, and then an intake for our LDH. But if you take that panel apart, if you can see where it's split in the center, that upper panel comes out pretty easy. The bottom panel, not so much. You got to take a lot of stuff off to get to it. But for our mechanics, we put an access panel in the dunnage area up top. And then, you got to make sure in your chassis, whatever one you pick, whether it be your choice of manufacturer, whether it be a third party, like the Spartans or, a different kind of cab, is it when you tilt that cab, that you can actually have good access to that pump. There's some that is actually, it's phenomenal. It's a huge, big area. And then a lot of manufacturers, depending on the body that you buy, the pump house that you buy, have to put a lot of reinforcement in that back wall there for the pump panel, to kind of hold everything together, which cuts down on your access inside the pump panel. So once again, something to look at. We were able to work with our manufacturer to get some of that taken out without suffering any kind of engineering catastrophe or cracks or anything like that. It's like, hey, we need to get more access for the mechanic to get in there. So now they have access, obviously from the bottom, from behind where the cab tilts, from both sides and the top. So, I mean, if Wichita does that, I mean, the mechanic should have no problem getting anywhere inside that pump panel. So, but I'm sorry.
Well, you touched on another one of our questions there when you mentioned manual valves and electric valves. Now, a lot of people use electric valves as their slow opening and closing valves versus the wheels. It's personal preference, whichever it is. But there are times when you can really shrink down the pump panel size by going with more electric valves. Now, a lot of times that means the valves themselves are you got no idea where they are. They can put an electric valve anywhere that it'll fit, just about, but it may not be able to be serviced. So one of the question I had was just manual versus electronic valves. Pros and cons. What are some of the pros and cons of each? I know you probably have your own preference. I have my own preference, but there's a lot. You come at it. I'm more operator oriented now. With my role in the fire company, you're looking at it from an overall fleet management and maintenance perspective, as well as when you get back to Ocean City. But but so just talk about some of those pros and cons, and maybe some of the trade-offs that occur. And now I'm going to throw a third part in there. Talk about the poor maintenance personnel and the poor EVTs that have to go in and find these things to service them.
Yeah, I mean, my first career pumper was a 1980 something Young, Dick Young fire apparatus, and it was the first pumper in Fairfax with electric valves. Oh my God, what a nightmare! Yeah, I mean, but Dick, yeah, but I mean, Dick Young, the Young fire apparatus. What an innovator in fire apparatus that guy was. I mean, he was so far ahead of his time with some of his ideas and thoughts and engineering, and then actually get him to work. I mean, I think it's probably youthful ignorance on the electric valves a little bit. But like you were talking about earlier with your engineer, is that you didn't get that feel. Like when you're pressing against the push pull rod or the handle or anything like that, you're not getting that feel with the electric valve. I mean, you're watching the gauge, to make sure that it's correct. But we kind of, as an organization, I believe we like mechanical stuff more than we like electric stuff. And there's an argument. So I'm sure there's a fleet manager somewhere. There's a engineer in Weldon, PA, that is going to tell me you're crazy. This doesn't happen. But I mean, I'm like, I just don't like a lot of electric stuff. I mean, I know that's our world, but I still like the push pull, and I think our members like the push pull. They like to be able to gate and feel it, as opposed to that valve. I'm sure electric valves have come a long way since the last time I've used one. But we're still using. There's still a lot of fire trucks that get bought in our organization that are outside of our not outside of our control, but are not in our standard, that are bought by some of the volunteer corporations that have a lot of the electric valves, obviously for the LDH, not much for the hand lines or the 2.5 inch ones. But I'm big mechanical. I like it. I know where all the dirt, grime, salt, brine, everything's going to go in our area in the Northeast. It's going to go right up that pump panel, and it's going to corrode stuff. But I mean, it could corrode the wire to the pressure governor. It could corrode the wire to the pump primer. It could all that stuff. It's just one less thing. I mean, I'm sure when we go out, what we got, a week and a half, or before we go out to the big show and at FDIC, and somebody's going to see this, and I'm going to get walking down an aisle, and somebody's going to say, give our electric valves a break, or give our electric valves a chance, whether it be for a 2.5 or something like that. And then not even electric valves, Chris. I mean, let's go back to my problem that we have with our pump. And I don't know if it's a problem, it's just an identified issue. Is that, what about flow meters? Where are they at? I mean, we got a pumper in College Park, Maryland that has, pressure and flow, and, and has, push, so I mean, it's a little bit of combination of everything, giving you all that sort of stuff. And I don't know enough about, all I can remember is bad things about flow meters. Is there good ones out there? Probably 100% there is. I don't see them on that many rigs, to the manufacturers that I go to. But, obviously I think the LDH intakes and discharges has a place, but, slow close valve works just as good for me. But I mean, what is your opinion on them?
Well, I mean, I really think, based on everything you just said, I mean, you really have to get out and look at this stuff and decide what is going to be best, for your organization. I do know that when we put together our 97s, they were built by Salisbury Fire Apparatus, not in business anymore. We had a specific, we had dimensions in the firehouse that were restricting the length of the truck. So, we had to have a certain size pump panel, and for whatever reason, I don't remember exactly what the engineering was. I was young then. I mean, I was only in for about 4 years when we bought them. The only real way to get to the size that we wanted was to use a few more electric valves than manual. It's been long enough now where I forget. I think there were some maybe 2.5-inch hose lines that we had them on. But as well as, the front intake and the rear intake, the large diameter intakes were all slow. I think that there is a place for them, like you said, but I think that no matter which one you go with, you have got to get the mechanics and the maintenance people involved in the location of those valves, because they're the people who are going to have to fix them or remove them to replace, or whatever it's going to be if something needs to be serviced. And like I said, the beauty of those electronic valves is that the switch can be put anywhere. You could put it in on the dash, really, if you wanted to. With the way it all works. But the switch, I say switch. I'm picturing the old. We had toggles. They were like toggle switches, and you could put them just about anywhere, and the valve can be located wherever you want. But it really is a maintenance issue. That is not to say, however, and this kind of gets into another one of the questions that I have. That is not to say that all manual is perfect either. Because depending on what you want to do, and I always think back to the trucks we had when I came in, and I've mentioned them before, the 81 LaFrances. I know for a fact that the pump maintenance people who we used were like dancing jigs in the street when they drove away, because they weren't going to have to work on those pumps anymore, because and it was all manual back then. And it was just, it was so compact and so difficult to get around, that, and the linkages were always falling off. This is way back in the day. So, we kind of became repair experts, not me personally, because I was still so new, but the engineering staff that we had at that time. So, you know, and there, I think there is a place. I personally like having them on the large diameter intakes and discharges, only because I feel like maybe it's just mental, but I feel like it's going faster than turning a wheel, and stuff like that. So I think there is a place for both. Generally, I am more of a manual kind of guy, but I'm also not going to let that stand in the way of progress on our apparatus. At the expense of something else. So I danced around that
Yeah,
pretty
I
good, Ricky.
understand.
I
But I
think
mean,
I think I
it's
did a
not
pretty
like,
nice job.
I mean, we like mechanical, but we have electric. I mean, we have an electric valve. I mean, we have an
Mm.
electric valve for our, our front intake. So that's, it's not, we're not opposed to all, we're just, I think we're just opposed to all electric valves. A little bit of combination of both. And, I mean, as great as a manufacturer we have, I mean, we've had problems before with angles of the pull rod, and breaking the ring around it, just because of the way the angle is. I mean, can you imagine the engineer trying to figure out the angle of every push pull rod for a pump house, and then it gets out on the floor, and then somebody's got to build it and put it in there, and it could be a little off. Where, like you're saying, is that, oh, I throw an electric valve in and I just run two wires, power and ground, and slap it on a pump panel somewhere. So once again, all depends on your organization, how you're going to operate, and then pump maintenance is another huge one that has to be done. Something we're starting to focus a lot on is that, hey, let's just not worry about changing the oil, changing the transmission fluid, changing the fuel filter. Let's get in there. Let's, check the packing. Let's get in here. Let's check that, we still have grease on the rods, all that sort of stuff, which, we haven't been doing as good of a job as we should, but we're getting better at it. And, hopefully lower some of these pump issue problems that we have later on. So.
The one other thing, it's interesting. So, like, first, I mean, for sure, the valves have come a long way since the young fire apparatus days. But what's funny is, and this is a different type of manual thing. The rigs that we have the preset pressures, for the different, for different lines. And I remember when the first one we got like that came in, I kept switching it to manual, and the last person I expected to correct me on this, because I was, I liked fiddling with the throttle and getting it, kind of the way but it was our chief engineer, and I mean he's well, he's not chief engineer anymore, but he's my dad's age. So at that point he was probably uh, early to mid 60s, I guess you would say, probably. And I just did not expect. He came up manual everything. And I mentioned, I asked how to do it, and he just looked at me and went, "Why would you want to do that?" So I mean, like, it's interesting, the different perspectives that people have over the electronics. I know one of the things I'm going to be talking to someone about next week at FDIC, or 2 weeks, week and a half, I guess. And this is getting a little bit off, and I'll bring us back, don't worry, but it's just multiplexing, and what, that is something that can be a lightning rod for one side or the other. So there's still a lot out there, and it really does, like you just said, and like I said earlier, it really does come down to what works best for your company, what works best for your response area. And sometimes in order to do what you want, everything is a trade-off with fire apparatus design. I've been saying that for many years. And sometimes in order to get that size pump panel that you want, you might have to go with more electric than manual than you'd like. But I did
to go back to your. I mean, I love that you brought up multiplexing. So, I mean, the only person that should be concerned about that is the mechanic. I mean, that is. I mean,
Yep.
God, I listened to a department argue with me, a firefighter, a guy that's hooking sealants and doing searches, and doing, all that fun stuff. And he's arguing that he has to have relay logic. I'm like, why do you have to have relay logic? Because it's more dependable. And I'm like, yeah, okay, I don't know about that, but who's fixing it? What does it matter? You, the guy that's forcing the door, hooking the ceiling, doing searches, cutting holes in roofs. What kind of electrical system's on the fire truck? Well, we want it to stay in service. Well, if you ask my mechanics, who they'll tell you that multiplexing they're able to fix the truck quicker, and they're able to get it back in service quicker through the diagnostics that's afforded through multiplexing. And that's all they needed to tell me. I know what a ground is. I know what a power is. I understand what multiplexing is and how it works, but I don't get in there and diagnostic, search for these power modules and all that sort of stuff. But our guys, I watched them do a relay logic truck for a day and a half to find a short in the pump panel light, and the pump bed light of the fire truck. A day and a half. So there's 8, almost 10, 12 hours of labor to find this short, where if it had been multiplex, they'd been able to find it within the first hour. So that has to go back to the guy that's going to fix the fire truck. The same way that they got most guys that fix the fire truck, or guys that fix the fire truck, told us you need to put access in here because your 45-inch pump panel is killing us. With the scrapes and the cuts, and we can't get to this valve. So you need to do something to help us out. So listening to that, we take a mechanic with us to do engineering. We take a mechanic to do final checkout, along with the people that are going to ride the fire truck, because it's two different worlds. It's this guy hooks ceilings and pulls the tack lines, is going to get stuff off the equipment, and this guy or girl is going to fix the rig, and they need to be able to get, like you said, to the valves, to the piping, to all the components that are on it. And, and that they're the ones that told us that, hey, you think when we tilt the cab on fire truck X, we'd have the same access that we have on fire truck W, but we don't. So figure that out, because we need access here. So it's important for those people to, to have their say.
Well, speaking of the maintenance, and I'll talk about your department specifically, and I'm sure there are certain things that are unique to yours, but I'm sure there are also common things that could be, common across the board. But once a rig lands for you guys, are there common problems that your shop encounters often that could be avoided with, the way I worded the question was proper PM, but I don't want to, I shouldn't say that, but could be avoided with a well laid out preventive maintenance
absolutely.
program?
It's, my goodness, I can remember for decades, and I know they've gotten out of it. Is even putting like Dawn dishwashing liquid, in the water, in the tank, and then and exercising the valves. I say that to somebody nowadays, and like, what do you mean Dawn dishwashing liquid? I'm like, it lubricates the valve, the inside of the valve. Obviously we still need the people to, make sure that the push pull rod or the handle is greased or, properly lubricated. Or if you still got, the valve that's got the teeth on it, to make sure that those are all lined up and they're operating correctly. Everything's tight. The pins that are in there, they're still there. The handles are tight and all that sort of stuff. So yeah, preventive maintenance is huge. And once again, something that we have a program, but we haven't been nearly as focused on it as we should be to help out with that. And one of those is pump maintenance, using, like the liquid Dawn liquid soap to help lubricate the valves, and then kind of keep some of that stuff free of all the dirt and debris. If you take one of these valves apart from a rig that, it's leaking by, and you look how bad it's corroded with the rust and the corrosion from the water, not from, most of them are plastic balls or stainless steel, how important that is. And let's go back to even the hose, and nozzles. They need to be lubricated. They need to be worked. They need to, every month the nozzle needs to be dumped in a bucket of water and run through, and that, flexing that shutoff valve is once again lubricating that ball valve. The ball valve that's in your nozzle is just a bigger size that's in your pump. Inside the pump it's a 2.5. This one's an 1.5 inch, but getting that thing properly lubricated and paying attention to it. We're getting ready to get on a huge pump testing program, and then part of that is going to be making sure that while we're getting the pump testing done, is that somebody else is going behind them, doing the proper lubrications, making sure everything's operating freely and all that sort of business. So looking forward to it. I mean, we do some of it now, but not nearly as much as we should. So.
Well, we've covered a lot today
about this great topic of pump panels. Such a sexy topic.
I'll tell you, I was kind of surprised that we've gone this far. It's been good. I did have a question about, because I just didn't think we were going to find that much, to hit on, but it was great. Some of the different directions we've gone. I did have a question for you though, and it's kind of a. I don't know if I'm going to ask it right, but I hope that you'll know what I'm getting at. And the way I worded it was, does a functional pump panel necessarily have to be neat and clean? And so like the example I was thinking of is, everything lined up perfectly. I mean, like in a perfect world, like you wouldn't have gauges all over the place. They'd be, right next to the valves that they're measuring the pressure on and stuff like that. But does it necessarily, I mean, like if it's going to take a tremendous amount of engineering and cost to get it to that point, and I guess if you're going to keep it forever and, that's worth the investment, to your individual fire company, that's fine. But does it, in your view, does it require that level to still be a functional pump panel where someone can get out and be efficient at what they're doing?
Let's go to that photo of that industrial pumper that we were talking about before the show started. That is neat and clean. That is about as neat and clean as you possibly can get. I mean, not only do we have all the handles in a row, the gauges in a row, and then it shows you with lines where to go. That is as neat and clean as possible. Is it functional for my fire department or fire departments around me? Absolutely not. There's some theories there that could work, but it's not. So let's just roll through another picture here and see what I think. But this pump panel works also, and the pump panel that we showed earlier on on our rigs on the driver's side, that is it's pretty clean, but it's not perfectly clean. Not there's not everything's in line. I mean, I can tell you that one of my people that work in my shop meticulously measures the distance between all those gauges to make sure that they're perfect every time we go out for a engineering conference or a pickup. But I mean, that's neat to us, as opposed to, a standard pump panel that we would get 10 years ago, 15 years ago, where the manufacturer more or less drove it rather than the customer. Because I mean, that all those pump panels, the Wichita pump panel that we saw, the industrial one that we just saw, that is a customer saying to the manufacturer, this is the way I want it to look. This is the way I want it to operate. And that's their individual. That's the great thing about the fire service in our country, is that some of us, I would say that in our area we kind of operate the same, but there's all kinds of different fire trucks. We would never have a Wichita fire truck, but it works great in Wichita. I mean, look at the LA City rigs or the LA County rigs and the San Francisco rigs. I mean, no two pump panels are the same unless they're from the same department and they standardize them. So I don't think you need to have it neat to be functional. I think you just got to have it where it operates. People understand it. There's some kind of standardization. And the most important part is our people and their training. Training on that pump, training on the thought process behind it. Like I said, it took a lot for me to sign up for this pumps class again, because I hate math, with a passion. I hate math, but I mean, it's important. I know how to pump that fire truck that we got a picture up here. I can get water out of every discharge. I can get it to the correct pressure. But the theory behind it, and then talking, once again, going back to our friction laws, understanding, impellers again, and, all those kind of pieces, you talked about the pump and the pressure governors today. Once again, I mean, you take your engineer from and Weldon, he's probably sticking his nose up at a pressure governor today, where you don't have to gauge it, the intake, and push the discharge to get it right. We're just going pressing a button, and we're getting 150 psi to every discharge, and everything's perfect. He's cursing at you, sticking his nose up at you. You don't know how to properly gauge down and you gauge your intake and gauge your discharges. It's an art form. I'm like, yeah, electronics took care of all that. So, but doesn't need to be.
Well, the one thing that goes absolutely, and the one thing that goes with that, in addition to your training, and this is what you said, but I'm just reemphasizing it, is knowing your pump panel, knowing it inside and out. Being that older engineer who can listen to the motor and know that there's something not right. But part of knowing that, one of the best pieces of advice I ever got, and maybe people would think this is silly, but I liked it, because the engineer who was training me said, like, when you're here, just by yourself or even with other people, just go up to the pump panel and not necessarily pull the valves, but go through the motions. Go through the motions of what you're going to do the first minute you get there. After you put it in pump gear, the first stuff you're going to do when you get there, and it becomes muscle memory after a while. No matter what your pump panel looks like, it's going to be muscle memory that you know exactly where to go to at least get that initial water out of the truck, so that then you can have a little break to start thinking about what you're going to be doing when they lay the line to you and all that kind of stuff. But knowing it inside and out is really, one of the keys to me. And that goes with the training, but it also kind of goes on, some of it's a little incumbent upon the operator to go that extra mile to make sure that not just relying on the class. And also, I mean, of course, I'm coming at it from a volunteer fire company, and it's 500 calls a year versus a department that runs a lot more and goes to a lot more fires, where they're operating the truck more, where they're operating that pump
there
in a real.
I mean, there's people that are running.
No, I'm just saying,
people running 5,000 calls a year who don't know how to operate their pump correctly.
Well, I'm just saying that my frequency with it is not the frequency that maybe your department has, in terms of having to use it on.
But it's what you put in. It's what you put into it. I mean,
yes, you get into it, what you get out of it.
Tony
what you
Kelleher,
put in.
Who's the operations chief in the DC Fire Department now, an incredible firefighter, but an incredible engine driver. He worked at one of the busiest engines in DC, and the amount of training he would put, the prospective driver through. I mean, I've watched them put the driver at the pump panel with a Nomex hood over his head backwards, so he can't see, and then he'll say, charge the 400, and then he would go by muscle memory, like you were talking about. One of Tony's big things is, if you touch it, you can remember it. It's just like they would go out and flow fire hydrants. And if you go out to that fire hydrant, you can look it on a map. You can go, it's in mid block, it's in the 300 block of First Street. That's what the map says. That's what, I'm looking at the map book. But if you physically go out to that block, touch the hydrant, turn it on, it's going to be more ingrained in your memory than just trying to learn it from a piece of paper. So, once again, a lot of the training that he would do is they would have the pump panel drawn on a piece of paper, and then you'd have to label each gauge, label each discharge, and they would go through that process, numerous times. And then you go out to the pumper, and then you're touching that discharge, touching that gauge, touching that intake, knowing where your pressure governor is, where your electric valve is to open up and close the front the front intake, and going through that process. I mean, Tony turned out some of the best engine drivers. I mean, look, we call them wagons. So, forgive me for my age. Is it, the wagon is the engine. So there's a lot of people that can drive a wagon, and then there's some wagon drivers, and that group, Tony Kelleher, turned out some great wagon drivers based on, they learned how to drive the rig. They understood the mechanical part of it, and they understood the pump. They understood the mechanical part of it. and they could also have the ability to operate it and understand it, and were intimately knowledgeable with it, because that's their job. And it doesn't matter if you're running 5,000 calls a year or 500 calls a year, the person is the one that has the most impact on that pump. Is that how well they can operate it and how well they know it. So, I could have a guy running 5,000 calls and get out to the pump and go, "Where's that discharge again?" Or it could be your guy that's running 500 calls a year and has put the effort in to know the pump panel, and then he's quickly moving through that process as opposed to searching for it. Like I did when I'm trying to find a 4-inch discharge in Ocean City. Ridiculous. So it's all good.
Well, Ricky, I want to thank you again for coming on with me today. Do you have any other comments just about pump panels in general you wanted to make before we sign off?
Yeah, they shouldn't be shiny. So they should be nice and black and, up there. So, no, it's all good. I think we covered a lot of room. I'm sure once some of my friends see it, like Tony or Nick Wilbur, or, they're going to have 10,000 things we should have said, or Eddie Rice for that matter. So.
Well, it's okay. They can come back and contribute. And, I got a water delivery podcast going at FDIC. They can all come. They can all come and sit down with Andy and Bill. And, it's noon on Monday. So if you're going to be out there at FDIC noon on Monday, you have anything you want to comment on, drop right in. I might have to cycle you in and out. We only have 4 seats, but, we'll get to you. But again, Ricky, thank you very much for joining me today. If you have any questions for Ricky about what we talked about today, you can let me know. I'm at chris.mcloone@clarionevents.com. All of our podcasts are archived on our website, fireapparatusmagazine.com/podcast. So you can go back. We just had a good one not too long ago with Nick Wilbur and his gang talking about rescue pumpers, speaking of pump panels and stuff like that. We're going to get into equipping them during our next one. So please, make sure you tune in for that. They're all archived there. And again, if you have any topics, I got a couple of good topics recently via email. If you have any topics that we haven't hit yet with any of our guests, we have a whole catalog of subject matter experts we can get on the show for you. So if you have a topic, apparatus related or equipment related that we haven't hit on yet, let me know. Chris.McLoone@clarionevents.com. So again, this has been Chris Mc Loone with you today with Ricky Riley. Have a good one and stay safe. Thanks again, Ricky. In the world of firefighting and public safety, reliability is key. That's why for over 2 decades, first responders nationwide have trusted the Fire Store as their go-to source for essential equipment, apparel, and accessories. From top-of-the-line firefighting gear like helmets, boots, and thermal imaging cameras, the Fire Store has it all, tailored to the specific needs of our heroes on the front lines. But they don't stop there. Their extensive selection also includes EMS supplies, safety apparel like flame-resistant clothing and high-visibility gear, as well as a wide array of tools, from hand tools to vehicle extrication tools, supporting public safety professionals in their duties. Partnered with industry leaders, the Fire Store's commitment to quality and excellence is unmatched, because when it comes to protecting communities, there's no room for compromise. Join the thousands of first responders who rely on the Fire Store. Visit thefirestore.com online or in-store today. The Fire Store, your reliable partner for fire and public safety equipment.